All right. Good morning, everyone, and welcome to getting started with OpenTelemetry in Kubernetes. So my name is Austin Parker. I'll be facilitating this workshop. Thank you all so much for coming. I hope everyone's staying safe and enjoying their quarantine life. So just a couple of programming notes. You can see there's a schedule that's accessible by clicking the little calendar icon up in the sort of the top part of the hop-in interface, and that'll kind of show you our what we're going to be doing today. So first part, we're going to be kind of going through an introduction to what observability is, what OpenTelemetry is. We'll have a short break, and then we will actually get hands-on with some code. We'll instrument an application with OpenTelemetry, and we'll deploy the OpenTelemetry collector. And then finally, we will kind of take all that data, throw it into Lightstep, and then use that to understand what our application is doing. So after that, there will be kind of a open Q&A, open forum, where we can all go into the sessions and just do like a big group chat if you have any questions that I didn't answer. During the presentation, or like while I'm talking, feel free to chat in the event chat to your right. You can just ask a question there, and I'll try to get to it. Also, just to kind of help me out, there's a poll, or there's a couple polls that I have running, and you can get to those by clicking on polls in the chat window. And so if you haven't already, go and answer those, and that'll just help me kind of get calibrated for where everyone is coming from. So I see a few of you all have done that already. Good stuff. So while that's coming in, let's go ahead and get started. So, like I said before, this is getting started with OpenTelemetry in Kubernetes. And I'm Austin Parker, Principal Developer Advocate at Lightstep. If you'd like to find me outside of this workshop, I'm on Twitter most of the time. Best place to get in touch with me, at Austin L. Parker, or you can email me, austin@lightstep.com. If you'd be interested in learning more about distributed tracing, which is what we're going to talk about a lot today, I wrote a book with a couple of my friends and colleagues called Distributed Tracing in Practice. It's available on O'Reilly. Find it at fine local bookstores everywhere. So, like I said, here's our agenda. We're going to start out by talking about what is observability, what's the basics of OpenTelemetry, how does it work. Then we'll get into instrumentation and deployment, and finally interpreting data. So let's start out at the beginning, and the beginning is observability. What is observability? It's a process and it's a practice. It's not. Different people will define, will say, oh, observability means this or observability means that, right? There's this kind of traditional mindset where observability means I have, logs and traces and metrics, and I have all these dashboards, and that's observability. But it's not simply about data sources. In a lot of ways, observability is about really these cultural changes that make it easy to ask arbitrary questions and understand your system. More precisely, it's the ability to take an arbitrary effect and then navigate back from that effect to what caused it. The difference between this and something in traditional monitoring or tools like APM tools, where they're very, I don't want to say siloed is kind of the word, but not really. But fundamentally, when you're looking at modern software, you have a ton of unknowns. There's a lot of things that you just can't really know from the jump when you're trying to, create software or run software, right? If you think about, we're going to do a pretty simple application running on Kubernetes, but just by saying Kubernetes, I've added this massive layer of abstraction that I actually do kind of need to understand in order to track down various bugs or issues. And traditional monitoring really is about, you're kind of saying, this is what normal is, and I'm going to set a bunch of alerts on what is normal, and then if anything goes past that, then that's a problem. But in the real world, normal and acceptable are kind of different day to day almost. If maybe your application is, normal is a certain level of traffic, and then you get a lot more traffic because you got on Hacker News or Reddit or something, right? You're going to have different problems and different questions at that level of scale, or that, those sort of spike incidents, than you will just on a day-to-day basis. And traditional monitoring doesn't really adapt well to that. So there's a lot of stuff that you might want to know about, and observability is really about taking all this stuff and giving you ways to ask questions about it and really interrogate your data. Observability is, this comprehensive process, and it's a holistic approach to understanding your entire system and not just like the individual parts of it. Now, one of the things that we believe at Lightstep is that distributed tracing is really kind of one of the core aspects of having an observability practice. There's this, I just talked about it a few minutes ago, but there's this notion of, logs and metrics and tracings as like, these are these three data sources. But what's interesting is that these are all fairly convertible from one form to another. We'll talk about it a little more later today, but if I have, the simplest way to think about this is if you have like an Apache, access log, you can turn that into a metric, right? This is a pretty standard thing. You use FileBeat or some sort of file processor to scrape your logs, and then over 5-minute buckets say like, okay, how many HTTP 200, how many 404, how many 500, right? You can do the same thing with traces. You can take traces and you can use those to generate sort of your rate, error, duration, key metrics, and also, use the fact that they're contextual logs to really dive down and get a lot of insight into what's actually going on for one single user. So you're getting a best of both worlds, right? You're getting, my 10,000 foot view and also my 10-foot view of a problem. So how does OpenTelemetry fit into all this? Well, one of the requirements for observability is to have high quality telemetry data. And OpenTelemetry as a project was designed to meet this need. I'll look at the polls real quick, because I asked if people have used OpenTracing or OpenCensus in the past. And it looks like most people haven't, but we got some yeses. So shout out to the yeses out there. And let's see, we got a lot of devs, got a lot of DevOps, cool. So the idea, if you're familiar with open tracing, right? The idea of open tracing was, let's create a API that is vendor neutral, that is language neutral, that kind of encapsulates a lot of the important things for distributed tracing, things like propagating context or span lifecycle management. And if those words are not familiar, I will get to them shortly. There was also OpenCensus, which was similar in that it was like, hey, we want to be vendor neutral, but it also, it had some different design decisions. It wasn't as decoupled as open tracing was. And so we brought these two projects together. It was over a year ago now. And the idea is that, hey, there should be kind of one, open source project that's widely supported by the community and vendors to offer APIs and SDKs and sort of all the tooling you need to generate telemetry from your application in order to use that as input to your observability system. So at a basic level, there's kind of three main components, right? There's the API, there's the SDK, and then there's sort of this set of components. We're going to start off by talking about the API and SDK. Now, if you look at the diagram on the screen, you can see I have an API package, I have an SDK package, and I've got these exporters. So I don't want to get too far into the weeds here because I'll explain more of these in detail later. But the basic idea is the API and the SDK are decoupled from each other. So if I'm writing a library, right, let's say I'm writing a database wrapper or a client for an API, I would only need the OpenTelemetry API because I'm not actually if I'm providing this library as kind of something that other people are going to import and use in their service, then I don't need to take that full dependency on the OpenTelemetry SDK. I just want the OpenTelemetry API. The API itself has this minimal kind of a no-op package that you can use for testing. But fundamentally, it's very lightweight. It doesn't really do anything other than sit there and let you create spans and traces and metrics. The SDK is the reference implementation of the API. Now, most parts, actually I believe all major parts of the SDK are re-implementable. So if you wanted to, you could go off and you could re-implement any part of the OpenTelemetry SDK you wanted, and as long as you satisfy the interface of the API, then it'll work fine. Now, depending on what exactly you're re-implementing, you might run into some problems with compatibility between that and the reference implementation. But as long as you're not messing with anything about context propagation, which we'll talk about here in a bit, then you'll be fine. Finally, you can see down at the bottom there's these exporters. We'll talk more about exporters later, but that's how data gets out of OpenTelemetry and into some other system. Now, the second big part, well, I guess the third technically, so we have the API, the SDK, and then tooling, right? So the tooling is not only this collector, and the collector is a way to sort of aggregate telemetry data from multiple service instances and then forward it on somewhere. But there's also tooling like agents for instrumentation. There's plugins on this collector that lets it do things like, for example, scraping metrics from Kubernetes or transforming telemetry data from one format into another, or even enriching telemetry data. So an example of that would be, let's say I have a website and I want to do a geo IP lookup on where my users are coming from. So somehow I get their IP address on the client side, and I put that into some of my telemetry and as an attribute, and then I send that to an OpenTelemetry collector. That collector can have a processor that you would write that would let you do things, basically just run arbitrary code, and you could say, okay, if I see this particular attribute key, take that attribute value and then go do a lookup on some service or reference it against some, something else, and transform the telemetry data in order to, to do whatever. Like, that's one example. There's plenty of other things that you could do with it if you wanted. There's, like I said, it's all open source, so you can go and you can, write your own plugins, which is nice. Now, what we're going to talk about later mostly is using the collector to aggregate and export data, which we will get to later on in the workshop when we start talking about deploying the collector to Kubernetes. So the API and the SDK each have several pretty important concepts that you need to understand in order to start writing or implementing OpenTelemetry in your software. So the first concept we're going to talk about is the provider. Now, if you're familiar with open tracing, let's look at that poll again. Yeah. So if you're familiar with open tracing, you might remember the global tracer. The global tracer still exists, but it's a global provider now. So what you can do with the provider is basically what we recommend. That's basically a singleton. You can do multiple providers if you want, but the provider itself is what holds sort of the configuration and the state for whatever telemetry instrument that you are using. So if you're creating traces, then you have a tracer provider. If you're doing metrics, then you have a meter provider. And like I said, you generally want one of these per service just to make your life easier. You can get multiple, if you're familiar with open tracing, you can actually get multiple tracers from a single provider, each with a different name, and those names will namespace telemetry data that comes out of them. So you don't have to create multiple traces. You don't have to create. Yeah, there's a lot of linguistic things that we've hit on here. A tracer in open tracing is equivalent to a tracer provider in well, it's kind of equivalent to a tracer provider because you get the tracer and then the tracer is what you operate on. Either way, the provider is your factory for creating tracers, creating metric instruments. So you always need one, and you should probably only have one per service. Moving on, tracers and meters are what you actually get from your tracer provider or meter provider, and these will let you create and record your spans or your measurements from your metrics. Context is another very overloaded term. So when we say context, we kind of mean two different things. There's the context that's inside of a process, and there's the context between processes. So between processes, you want, if you have a trace, you want to be able to, one of the big important things for a trace is that, I have service A and I have service B. And when a call RPC goes from service A to service B, I need to have some information. I need to have an identifier that says, hey, this is the call to the service, this is service A's trace ID, and this is the span that came before you, so that when service B creates a new span, it can say, okay, I'm part of this trace, and that span was my parent. So when we talk about context, we're usually referring to that, but keep in mind there is also in-process context, and that varies based on language. If you're in a language with threads, then that looks different than if you're in a language that doesn't have threads, for example, like JavaScript. Out of the box, OpenTelemetry API prefers the W3C trace context standard, but it also supports Zipkin headers or B3 headers. Finally, the last kind of core concept in the API is this idea of semantic conventions. So semantic conventions are really attributes for common resource types, things like databases or compute instances, deployment services like Kubernetes, and these are ways to sort of say, how do I represent a host name in OpenTelemetry? Well, there's a semantic convention for that. How do I represent a database instance in OpenTelemetry? There's a semantic convention for that. A SQL query, again, semantic conventions. So these are actually defined at the API level and can be extended by extending the API. Support for this the thing to keep in mind about semantic conventions is, right now OpenTelemetry is in beta. These conventions are being defined still. You should start using them, even if if you're using a commercial or even an open source like trace analyzer, they might not understand all the semantics yet. But as adoption of OpenTelemetry increases, I would expect that you will get more sort of adoption of people building features on top of these semantic conventions. So it's a good idea to be familiar with them now. In the SDK, there's 3 core concepts: processors, exporters, and sampling. So processors I talked about them in reference to the collector, but it's also something that exists in the SDK itself. Now, normally you're going to see these really in this context of like what happens to a span when it's done. So the export pipeline for telemetry data, right? However, you could do other things here too. You could write custom processors. One example would be, let's say your application or your service touches PII, and you want to make sure that no PII leaks into a trace. So you could create a custom processor that ran like a regular expression, or ran a regex across every span it sees, all the attributes, all the events that happened on it, to make sure that, hey, nothing that looks like a social security number or a tax ID number is in this, right? Looks like we might have a question. Can it handle EJB remote call context propagation? I don't know if it can right now, Chris. That's enterprise Java beans, right? I know in Open Tracing there was like a plugin, I want to say, for like some enterprisey Java stuff. That might work out of the. I don't know if that would work out of the box, because it's actually in the propagation layer, not in just like the tracing part. It's a good question. Let's follow up at the end. I will, and I can also point you to where you can ask or put suggestions like that into the ears of the project people. So where was I? Okay, processors, right? So you could have a processor that stripped that that stripped out social security numbers, for example, or basically anything else. Like I said, all you have to do is satisfy the interface and add that on. Exporters are little packages that basically they do what they do what it sounds like on the tin. They export your data. So OpenTelemetry has its own data format called OTLP, OpenTelemetry Protocol, and some systems, some backend analysis systems will support that natively. Lightstep is one of them, and I would personally expect that you'll see other companies, other commercial vendors support OTLP natively eventually. But if they don't, then you need some sort of exporter to transform the data from OpenTelemetry format into Jaeger or Zipkin or Datadog or Google or whatever format, right? So you can use exporters at the SDK level, or you can use them at the collector level. And we'll talk about both of those later on. Finally, sampling. So sampling is controlled by the SDK, and sampling is what it sounds like on the tin. So if you're taking a sample, a random sample of spans that are created, and actually recording them or creating them. Now, You can do this in a couple different ways. You can do this conditionally. So there are, a simple sampling algorithm would be, 1 out of 10 spans gets created. There are also several different other algorithms things that will create control span creation to have a constant rate of span creation. So, for example, always have 10 spans per minute or 100 spans per minute or 1,000 spans per minute, regardless of traffic level. And they use various algorithms to ensure that rate. There's also sort of the simplest one, which is always sample, right? Always sample everything in. And that's actually what I personally recommend. In most cases, it's usually good to start by saying sample everything and then either tune what you're sampling kind of later down the line, either at the collector level, or if you're using Lightstep, we do dynamic sampling, so you don't have to worry about it. But it's generally better to pay the overhead penalty on your service just to make sure that you're not losing anything interesting due to client-side sampling. The OTel collector, if you want to stay all open source, does offer a tail-based sampling approach, and there's actually a plugin for it. I think Elastic wrote it, that will ensure that all spans for a single trace go to like a single collector instance, so that you can do intelligent tail-based sampling. And that would be something like, if there's an error, I want you to always sample that in. I want you to always record that. We'll discuss a little bit more about some of the sampling options and how to configure that later on in the workshop. Finally, a couple of I've talked a lot about spans and traces, and just to make sure we're all on the same page about what these all are. So a span is a unit of work, right? If I have a service that is, think about it just at a 10,000 foot view. Let's say I have an application and I click a button in my application, and that button connects to some backend service that calls into a database to get some piece of information and then return it back to the client. So each sort of logical step there, at the client clicking the button to getting a response, at the backend receiving that request, handling it, sending the request to the database, and then the database client, running the query and getting a response. Like, each of those separate logical operations would be a span. And a span is kind of constrained to a single service. And spans have a couple of attributes, or properties, I should say, to distinguish it from attributes. All spans have attributes, and these are key value pairs, where the key is a string, the value can be a Boolean, a string, or a number. And this is what you use to sort of categorize, filter, search, sort your traces at the end of the day. Spans can also have events. These were logs in open tracing. And these are simply structured event data. So you can have attributes on an event. You can also have like a message, so a stack trace. This is where you would put kind of your logging output. This is where you would put stack traces. This is where you'd put any kind of, event that you wanted to keep track of. One example of this, let's say you have a mutex, right? You're waiting for a lock. So you could have a event that said waiting for mutex. And then once your service had captured that mutex, then you write another one that said got mutex, right? So those are your events, right? Those are your kind of discrete things that are happening in your code that you would want to know about later. And when you're looking at this stuff in your trace your trace viewer, then it's very easy to then see like, oh, this one took a long time because I was deadlocked, or I was waiting for, I was waiting for this mutex to come free. And there's one really cool property about events in OpenTelemetry is that an event timestamp is actually an offset from the beginning of the span, so you can very easily see like, at 1 millisecond in, I started waiting on my lock, and then 112 milliseconds in, I got my lock, so I can see exactly how long I was waiting. Question from the chat, Barath, hope I got your name right. Should spans be created all along from the root to leaf nodes of call execution to obtain trace for a workflow execution? So I'm gonna give you a strong maybe. If you're trying to trace like a workflow across a asynchronous like queue, or something that has a lot of like fan out, fan in, it really depends on a lot of things. Like, one is, how long does your workflow take? Like, if the entire workflow takes like seconds or maybe a minute to complete, then sure, like, record everything off of that one root span, that one root node. But if it's a multi-day or multi-hour process, then you might be better suited by creating individual traces and then using what's called a link in OpenTelemetry to associate each of those individual traces with each other. I don't talk a ton about links in the workshop, but I'll talk about them now because this is a good place to talk about them. And I'll talk about them in context of a span context. So I mentioned earlier, this context idea, right? You have to propagate context from one service to another service. But what if, you have something that isn't this A to B sort of RPC relationship? Or what if you are, what if you're moving past like a security boundary of some sort, right? Like, I'm going from an untrusted system to a trusted system. For these and a lot of other reasons, there's this concept in OpenTelemetry called links. And normally in sort of an A to B RPC parent-child sort of call, then the span context of a span is injected into the transport, so it's injected into like the HTTP headers, and then on the receiving side, those that span context is extracted, and then a new span is created as the child of that span context. However, you can also create that new. Rather than creating it as a child, you can create it as a link. A link if you link two traces in that way, then service B would not continue the previous trace. It would create a new trace, but they would have a reference to the old trace in the link property of that new span. So if you have like a very long running kind of workflow, then you would probably want to use links in order to correlate everything together. But in general, it's best to, span-based tracing kind of implies that things happen kind of close together. So if you have this like really big fan out, then that happens quickly, do parent-child. If you have something that happens more slowly, or if you have something where the outcome of an RPC does not necessarily influence the success or failure of the parent, then that would be a good choice for links as well, because you're not necessarily representing like a success failure relationship. A lot of this gets into like the point of tracing in a lot of ways is to model, like to logically model your system. So you need to understand what the system is trying to do and then get everything to sort of match up right. And there's some of that is a judgment call. It's a good question though. Also, I should say the span context also is what has like sampling flags, and then there's also something called trace state, which is vendor specific tracing information. We won't really talk about that much more, but know that it's there. Finally, there's correlation context. So if you are familiar with open tracing, then correlation context was called baggage in there. I actually think that it's being renamed to baggage in the trace context spec, but I'd have to go look at the meeting notes. However, the idea with baggage or correlation context is that you can use this to propagate telemetry attributes that aren't necessarily the trace ID or span ID or sampling flags, right? So this would let you kind of take some arbitrary, if I go back to my like push a button on the client and something happens in the database, you can use baggage to, at the client side, inject some attribute that my, like a customer ID or a feature flag value, right? Like some information that's only necessarily only available at that point. I could inject it in there into the baggage, and then that baggage propagates down to all the child services. So in general, you have a couple different usages for this, but in the context of telemetry, it's generally going to be used for, if there's some attribute that you really want to add to everything, to every individual span. Actually, a good example of this would be through workflows, because like a workflow engine, because you might want to send information from like a, the initiating process into all of its subsequent job runs, without necessarily being able to get that information any other way. It's kind of an advanced topic. It's something that is there that you should be aware of, but it's not something we're going to work a lot with today, but I do want you all to be aware that it exists. All right, another question from the chat. Loving this energy this morning. Sib, understand logs will be eventually added to the OpenTelemetry framework. Your current slide indicates we can embed logs as events and traces. What's the difference between events and logs in this context? In other words, what's the use case for adding the third pillar to OpenTelemetry? So caveat being, I am not I don't really go to the log sig meetings. I don't actually think that the interest is necessarily in creating another logging API in OpenTelemetry. I really believe that the idea behind the logging sig is more to agree on like what should structured logs look like for OpenTelemetry. How can we ingest them into like the collector processes, or scrape them from something? And keep in mind, log data can be transformed into span data or metric data, so there's a certain level of OpenTelemetry needs to kind of understand logs, even if the goal isn't to provide a logging API. From a developer's point of view, you can think of a span as simply a structured log event that has this additional context layer, right? So when I'm talking about an event in OpenTelemetry, this is, realistically, this is where you would put logs. If you were doing something completely greenfield and you were writing your own service just from the ground up and you were saying, I'm just going to use OpenTelemetry, then I think instead of writing traditional log messages, you would actually write events into your spans. And then if you wanted to, hopefully this is something that we can get to with the logging sig eventually, is you could either output those spans as spans, or you could output them as like a common logging format, right? Or OpenTelemetry could transform your spans into some other well understood logging, log file format. That's a little speculative. Like I said, I don't sit in that SIG, and I've also been on vacation the last 2 weeks, so I'm still catching up on a lot of stuff. But that's really the effective difference. Like I wouldn't think of the OpenTelemetry logging stuff as necessarily a, hey, we want to do another logging API. I would think of it more as, how do we interoperate with existing logging APIs, and maybe even, again, speculative, but what if there was a way to, you have a SF, L4J, whatever, Neo4j, some Java application with a bunch of logs in it. Like, is there a way that we could hook into that logging API, inject context prop, and then create spans for you? Like, But those are the sort of, being logging aware and supporting logs, I feel like, are kind of prerequisites in some ways to get to that point. Another question from Robin. What's the difference between the info and the MDC and what you get in OpenTelemetry? That's map diagnostic context, right? So, similar purposes. One thing to keep in mind with OpenTelemetry is that it really is designed for this idea of polyglot environments, and for consistency across multiple languages and multiple frameworks. So if you're in the Java world, then yes, there are like 40 billion options here. And some of them maybe are going to have features and capabilities that OpenTelemetry doesn't right now. But if you're like writing Go microservices, then a lot of this stuff doesn't exist, and so OpenTelemetry is very valuable there. But let's say you have like Java and Go microservices. Now with OpenTelemetry, you can have kind of one answer for both sides of this equation, and a lot of tools that support this format, so that people on different teams, people in different parts of the organization can understand the data because it's presented in a consistent format, with sort of cool advanced analysis tools. I hope that answers your question. We'll have some room at the end for more, but for now, we're actually coming up on our first break. So what I'm going to do is we're going to check the schedule here. So a 15-minute break. What I'm going to do is I'm going to put this up. So if you want to follow along with me as I go through sort of the workshop stuff, then this slide here, this has the GitHub repo and sort of the prerequisites. Sorry, I wanted to email these out to everyone, and I didn't get a chance to. Like I said, I've been out for a couple weeks. But we have 15 minutes, so if you don't already have this stuff and you want to get it, go ahead and get it. If you just want to like hang out and watch, that's fine too, and you can kind of follow through this later. There is a README on that repo, so you can kind of do this at home. But I'm going to go grab a water, and if you have any other questions or want to chat amongst yourselves, feel free to chat in the event chat, and I will see you all, or I'll be back in a few minutes, and we'll get started here in about 15. I'll see here. Put on some music for you. All right. Welcome back to the workshop. I hope everyone had a great break. I got some sparkling water. Okay. So, recap. We talked a lot about OpenTelemetry and observability. Now we're going to talk about instrumentation. And what is instrumentation, first off, right? So we need to instrument our software to generate this telemetry data that we then use to understand our system, right? Now, there's generally two ways to do this. You can rely a lot on sort of automatic instrumentation, either through sort of an agent-based approach, something that is instrumenting your code for you at runtime, or through library wrappers. Kind of depends on the language. Like if you're using Go, then you're going to use a lot of library wrappers because just the way Go works, there's not really easy hooks for runtime instrumentation. In Java, there's a lot of good ways to do this dynamic instrumentation. In general, you're going to want to do both, though. Like this isn't a either or. This is a and. So, like I said, we're gonna go through this workshop together. Feel free to follow along. I will probably be going a little fast, but if you said you can keep working on this after we're done. So let's talk about what our actual application does. So let's imagine we have a to-do application that's pivoted to keep track of the other favorite thing on the internet, facts about cats. Now, what we have is a pretty straightforward Spring Boot application with a Vue.js client. But if you've seen it, or if you've managed to run it already, then you'll note that the cat fact part isn't working right. So we're going to use OpenTelemetry to figure out why. Now, before we start, or one thing we can actually come back to this later, but we'll also need a Lightstep account. So if you pull this up. So if you go to this link, I'm gonna drop it in the chat. So you can go there and you can sign up for Lightstep, and we're gonna use the Lightstep account to actually understand what's going on in our application once we've instrumented it. So while I'm kind of going through this, click that link I just dropped in the stage chat and go through there and we'll get you going. So here's our application. As you can see, we have 3 directories. We have our client, we have our Helm chart, and we have our server. There's also a codefresh.yaml because you can use this on Codefresh. And we'll start with the Helm chart actually. So this has a couple of, I'm going to fill this out with my information. You don't have to use the same thing, but if you want to actually publish these images and pull them from, like if you're using a hosted Kubernetes cluster, then you would need to actually set this up right. But you can also just add whatever tag you want here or whatever prefix you want, and then as long as your clusters, your minikube or whatever is set up right, then if not present, we'll pull from your local Docker repo. So for our service type, I'm gonna pretend I'm gonna run this locally. So if you are using this on a managed Kubernetes thing, then you will want to use like load balance or something rather than node port. You can also use node port and just use IP addresses, but we're going to use node port, and I'm going to do port 30,000. I don't need that. We're going to run the server on port 3005. The MySQL stuff you can just kind of keep as default. And then I'm also going to get my Lightstep key. As you can see, I have worked on this already. So when you're in Lightstep, if you go to your settings, which is the gear, you go down to access tokens, you'll see, it won't look like this, but you'll see an access token. So you just copy that by clicking the copy to clipboard, and you will add that to your values.yaml as Lightstep key. And this is going to be our basic setup for now. So we can look in here. There's a, I don't want to get too down in the weeds on everything, but this is mostly set up kind of automatically for you. And if I go in and I helm install to-do helm to server what did I do wrong here? 17 server. Oh. Helps to save your changes. It actually works, I think, fine without quoting the port numbers, Jesse. I didn't save, though, and so it was missing something. So now, after running helm install, we give it a minute. Let's get logs off of our server. Wait for this to come up. So while we're doing that, take you through the server code a bit. So again, very straightforward Spring Boot app. And you know, I have a to-dos, to application, to-do repository. Here's my new cat fact controller. And all this is really doing is this is hitting a remote API on a Heroku app. Oh. So the other thing you'll want to do is change the name oh, this is a problem for me, not for you. I need to rebuild my container though because it's looking for stuff that doesn't exist yet. Gotta love workshops. All right. So we have our server. We have our server code. It's pretty generic stuff, right? We're building everything into Docker. You know, it's running it. On the client side, it's also pretty straightforward. We have a API layer here that will get our to-dos, get our cat facts. We have our view components. Here's our to-do code. And most of this we actually, one thing that's cool is most of this we won't actually have to touch at all to instrument this code, which is nice. just let this finish building. And then we'll need to build the client. So as that's building, let's actually talk about how to instrument this. Like I said before, there's two options. There's automatic, there's kind of automatic and manual. And generally what you're going to want to think about doing is start out with automatic where you can. Not every language is going to have that option. But if you do, that'll give you a good jump start. So for Java, we actually, there we go. Oh. All right, now that'll finally work. So the best place to find all this information is on the OpenTelemetry GitHub account. So you can actually go here and you can see, here's every SIG's, output. You have a specification, you have like the .NET client, you have C++. What we're going to use for Java is we're going to use this OpenTelemetry Java instrumentation. And what this does is this is a jar that you can drop in to your Java application, and it will automatically instrument it for tracing. If you look down at the bottom of the README, you can see here's all of the different frameworks and libraries that it supports. So everything from your Jetties, MongoDB, Kubernetes, Netty, OKHTTP, Servlet framework, Spring, Twilio. Bunch of stuff is kind of just there out of the box. Adding this in is pretty straightforward. So what we're going to do is we're going to first, we need to add the Java agent to our Docker container. So we're getting the latest release, which is 0.6.1, and we're downloading it into the container and adding it as app/otel.jar. Then what we need to do is we need to configure it. So we're going to say we need to tell it what the name of our service is going to be. So service.name, we're going to say to server. And then we're also going to need to tell it where do you want to send telemetry to. So like I said before, you can either you can do this in a couple different ways. What I'm actually going to do is I'm going to set this up for the collector, which we'll kind of add in the next step. But this could also be, you could send this to Jaeger, you could send this to Zipkin, you could send it to anything that has a Java exporter. But since we're using OTLP, OTLP endpoint, OTel collector 55680. And then in our Java, in our entry point here, we want to say Java agent app hotel.jar. So we want to tell the JVM to use hotel.jar that we downloaded up here as our agent. And save. And honestly, like that's it for now in the, like, this will automatically instrument my application, instrument Spring for me. I will start getting traces from this once I have a collector deployed. Just to show that it's working. Yeah, okay, so here's the problem we're running into, right? This is, once you've built and run everything, go to localhost port, whatever, and you'll see that, oh, you're getting an exception when you try to get a cat fact. How can we figure out what's wrong? Well, first, we obviously have to instrument this. Well, I did that. Like I said, just one line is all I need to do to add that in. However, there is some other stuff we can do with this, and sometimes it's, like I said before, you might want to mix automatic and manual instrumentation. So since I know that, like, my problem is in this cat fact class, or this cat fact controller somewhere, I can go in and I can add a import to this automatic annotations thing. So, you know, if you're used to Java, you're probably used to being able to put these little, you know, at whatever, these little annotations to your methods. So I can go in and I can add this import, and then I can go down to my actual API method where I'm calling that remote API and just say with span. And now what'll happen is whenever this controller gets hit, it'll actually create a new span that sort of captures the work being done in just this get cat fact method, which is very helpful. And then I just need to make sure that I've added that. I will need another import here. So I'm going to go to my Gradle file. I'm going to bring in this auto annotations. And that's that. So now, you know, I'm also going to build this just so that'll be going on in the background. So that's the server basically done. What about the client side? So the client side gets a little trickier. You know, it doesn't have quite the nice and neat, you know, add one thing, add a jar file. And it's actually a little more complicated because we, you know, since it's running in the browser, we need to actually, you know, run client-side code. We need to integrate this in a little more deeply. However, we can still perform like a good separation of concerns. So if I go, I'm gonna make a new file here, and this is gonna be tracer.js. And tracer.js is, what happened here? We'll come back to that. It looks like GitHub didn't like downloading that file. Let's go to the client real quick. We're gonna need to install some stuff. So all of the OpenTelemetry packages are in this add OpenTelemetry namespace. We'll want a context package. We'll want OpenTelemetry web. We'll want some plugins here. We'll want an exporter to the collector. And that should get us the new version of all these. And we're just gonna sit here and hope and pray that Whizzle2 doesn't destroy my life. Great, that worked. So now back in our tracer.js, we need to import all this stuff. So we have our exporters here, web tracer provider. If you recall what I was saying about tracer providers, this is what actually gives us the tracer. We have these plugins, and this will actually automatically instrument XML HTTP requests and user interactions on a page. Oh, we also want document load plugin. This will capture page load events. This zone context manager, this will help us with asynchronous operations, making sure traces are correctly generated there. And then the collector trace exporter will let us send these traces to a collector. So we're going to add this. These are sort of some predefined values that actually get, they come in through Helm, where we're passing variables to a client-side app is a pain. But what you can do is you can use a fun trick with Kubernetes config maps to write sort of config objects into your app container and then use those to pass in config. It's a neat trick. So we need to configure our exporter. The service name will be to-do client, and our URL is going to be the collector URL. So the service name is what is the logical name of the service. We named the server to-do server, so we'll name the client to-do client. And the URL is where we're sending this to. And again, this is going to go to an OpenTelemetry collector. Now we need to configure our provider. And we need to configure our plugins. Now, by default, if you don't specify, if you just create this, then it'll automatically try to load every plugin that's been imported. We do want to add some config for this one, though. We want to ignore the sockets that it opens for. Basically, we want JS node. It can send data, or you can get telemetry back from itself, which we can use ignore URLs to ignore. And then we want to propagate our headers to URL. And we want to make sure that we're propagating trace headers to our backend. Normally this wouldn't be a problem, except you might actually probably not have to do a lot of this as long as you're putting everything behind the same URL. But because just when I was building all this and testing all this, a lot of times it would get mad because localhost or IP addresses or whatever. So just easier to add that. But you can also use these ignore URLs or propagate core stuff to basically say I only want to trace certain requests from the client, right? I only want to trace back to this service. Once we've got that, all we got to do is add span processors. We'll do a simple span processor. We'll do our console span exporter, and this is just so we can see things in the exporter export options. So our couple notes on this. Span processors, every registered span processor will execute for all traces, right? So if I have 3 different destinations, everything will go to them. And then we just have to register it, and we're gonna set our context manager to this zone context manager. And again, this is just for async fun times. Now, if we go back into main and we import this, generally you want to import your tracer and this provider early so that it can hook into everything. So you want to, in this case, if you import it very first, that makes document load work, right? Because then it'll be the first thing that gets loaded. But you definitely want to make sure that if you're trying to trace like fetch requests or XML HTTP requests or whatever, you need to make sure that you load it before any requests go out that you want to trace, because the way this works on the back end is it's using Shimmer to kind of patch open, connection open, connection close, stuff like that. So now we have our tracer, we have all that set up. So we should be able to build all this. To do client. And while I'm building that, let's talk about how we're actually going to get this telemetry out. So we've added to this, and we don't really want to send it straight from the process to Lightstep, right? What we want to do is we want to deploy a collector. Now, if this was the real world, this was prod, then you would actually probably want to run a collector on each of your nodes as an agent, and you want to deploy this with a daemon set. And then you would want like a deployment of standalone collectors behind a load balancer. You'd be load balancing gRPC traffic, and those collectors would then be what exports it to its final destination. Now with Lightstep, you don't need that second standalone collector. You can use our satellites for that. What we're going to do is we're going to ignore we're just going to kind of do a hybrid here. We're going to deploy one collector that'll get the telemetry from both of these, and then go from there. So to do this, we're going to need to make some changes to Helm. So first off, you remember in the client we added in, we changed our config file. So just gonna make sure that these are synced up. They aren't. So in the config file, we added in those new values and those collector and server base values. So I'm just going to go in and add those here. In the Helm chart, we've updated this to add those. Well, all this is really doing is this is just going to write this config.js into the container or into the pod. Yeah. So we're volume mounting that config in, and this is what the client loads to get all of its config for where things go. You don't really have to worry about it, but you do need to make sure it's up to date. But now to deploy the collector, we're going to need a new chart, or not chart. We're going to need a template. So we're just going to call this collector.yaml. And I already have all this configured. Oh, so I'm just going to paste it in, but I am going to walk through this real quick and show you kind of what it's all about as I fix the problems in my things and rebuild the containers and da-da-da-da-da. All right. So for a collector deployment, there's a couple of key things on Kubernetes. So you need a config map to give it its config. This is the configuration for a collector is a YAML file. So there's kind of 4 big parts: receivers, processors, extensions, and exporters. Receivers are how it receives telemetry data. In this case, we're using OTLP format, and then we need to define a gRPC endpoint and an HTTP endpoint. The gRPC endpoint is what our Java service is going to use. The HTTP endpoint is what our client is going to use. So we're putting the gRPC at port 55680 and then the HTTP at 55681. This also supports mutual TLS. If you would like to learn more about that, check out the collector docs on their GitHub. Processors allow, similar to processors in the SDK, let us process telemetry data. So in this case, we're saying batch and queued retry. So batch just means that it will batch up data and send it to the exporters. Queued retry has some options for like exponential backoff and things like that. You generally want to use this just to make sure that you're not dropping data. Extensions, health check is super useful because this lets us, this gives us a health check endpoint that we can use for our readiness and liveness probes. zpages, this is optional, but zpages, you can access this. I think it's at whatever the port number is /healthz/traces or something. You have to look at the docs. It's a good question, Sib. I'll get back to it, okay? zpages lets you like look at the inner workings of the collector though and debug stuff. We're also registering some exporters. So we have Prometheus exporter. This is exports metrics about the collector to Prometheus on this endpoint. We have a logging exporter, which logs things. And then we have our OTLP exporter, which is pointing to lightstep.com. And then we're taking that Lightstep key that you should have from your project settings in Lightstep. This guy. That'll get inserted there. Finally, we set up the service, we register our extensions, and then we say we can define one or more pipelines. And you can do a lot of stuff with this. Actually, you can say certain, if this matches this prefix, then send it to trace pipeline A versus trace pipeline B. There's a lot of configuration options here that I'm not going to have time to get into, but it exists. So we're going to receive traces of our OTLP, we're going to process them with our batch and queued retry, and then we're going to export them to our logging and OTLP endpoint. So the service config is pretty straightforward. Value, it's not really super interesting. The deployment is a little more interesting. So we're only going to do one replica, but you could do more if you wanted. Your containers. So we're setting the config to this OTel collector config.yaml, which we will volume map in later. There are memory limits on this that you'll want to configure. Memory bal should be max 1/3 to half of the memory assigned for the container. Image will be OTel/OpenTelemetry collector. So you can see here that our limits are 2 gigs, so we're setting the ballast at about 1/3 of that. Opening up some ports. Here's where we're mapping in the volume mount. And then here's our probes for readiness and liveness. So if you want to actually look at that too, I'll send the final version of this. So if you want to look at what it looks like after all the changes have been done, I just put a link in the chat that takes you to sort of the final version. All right, so that built. Now let's build the server. Not found. Well, something changed in the world. Let's see what it is. Looks like they pulled that release. All right, so in server, in this Docker file, don't do 061, do 060. All right, while that's going. Sib, okay. Custom spans. If you want to enrich every span with default attributes, it's a good question. There's a couple ways you can do it. If you're using the auto instrumentation, then what you would probably the easiest way to do it. I will say it depends on like exactly what kind they are, because you can go in and you can use the like if they're an actual resource, if there's something that's like I want to have every span have the version number or the host name or some data piece of data like that you don't have already, you can use this OTel resource attribute environment variable, and you would like if you want to set that in the container. So we can do like this. Let's say I wanted to set a version resource. Then all I have to do is do this OTel resource attributes. Oh, I actually need to do them all on the same line. My bad. This version. So this would add that attribute to every span that gets created by the tracer. Is it? Not found. You know, this was not the part that I felt like would break, y'all. Oh, because it's a different name. All right. The joys of open source. Okay, one more time. Oh, that's for Java. So if you wanted to do that like on the client side, then there's a, oh gosh, what is it? Yeah, so you can do resources in the same way here on your JavaScript side. So I think it would be, yeah, resource. I believe that works. So you could add them to the provider. You get resource attributes to the provider, and then every span that gets generated from that provider would have that attribute. So that would be probably the best way to do that. Re-download. Okay. So now that I've gone through and done all of this, let's upgrade and let's see. Did I save that? We're just gonna delete and reinstall this because I can never remember how to get Helm to cooperate. Oh, you know what? I know what I forgot. I forgot some values. There we go. So in your values, in the values file, you also need to specify the service type and then some ports. So is everything running? Let's check. That's running good. Kubernetes logs to do server. Give that a moment. I think it's almost running, almost up though. So one thing you can do, since we did, especially on the client side, since we did add that console logger, so you can actually go into the console and you can see like there are spans being generated now. So here's like my document load spans. Oops, I don't want breakpoints. So yeah, you can see here's like my traces that are, my spans are being generated by the client-side instrumentation. It looks like the to-do app finally works, so I can go and I can add a to-do, check this out in Lightstep, and you can see traces are being generated there. I can also go in and look at the collector, and you can see that it's exporting spans. And then if I go back to Lightstep and I go into the Explorer, suddenly I have all these traces, which takes us to the last part. We're gonna start exploring our data, and yeah, I'll kind of do this pretty briefly. I want to leave some time for like the one-on-ones or the group session at the end. But if you recall, what got us down this entire thing to begin with was figuring out why our cat fact wasn't working. So if I filter this to server and operation in fact, I should see, here's the thing. And then here's my cat fact controller. So it's looking it up okay. But it shouldn't be. Refresh this a couple times. Interesting. Seems like something changed in this because it actually should be showing an error here. A couple things to point out though. Yuki, remember where we set those resource attributes? So here's like version, service name, the stuff that we set in the environment variables. And I can also just to point it out, you know, the trace is starting on the client and then it's going to the server and then it's going down into this HTTP GET request. And I can look at everything. Not super interesting because it's a low volume of data, but if there was a lot more stuff, then we could do, like, we can really use like correlations more. Yeah. But we are able to kind of go over here and look at and see like key operations in the client on the server. So we can look at, you know, here's our getting our to-dos, getting the facts. We can see rate, error, latency. We can also see on the server, remember where I said that service.version? We can see that Lightstep has detected that version number. So if I was to go in, change something, and then redeploy with a new version number, then you would get another deployment marker for that version changing. All right, so what I want to do now is I'm actually going to jump over into the sessions, and then you'll be able to kind of, I see Ian has a question. I'll answer it over there, but then we can kind of jump in and talk a little more one-on-one in the time we have left. So I will see you all over there in a moment.